Well, happy Thursday, everybody. We are almost done with our week and looking forward to spring break next week. This has been week 10 for us, and this is the third day that I'm coming to you with a lesson. So hopefully you have been participating in Tuesday's lesson and Wednesday's lesson, and now here you are today. What you see on the screen is your DNA chart. DNA box. So as I talk a little, go ahead and copy that down onto your paper. Remember to include the date, topic, EQ, the DNA. A lot of instructions there, so I give a little bit longer today for you to write that down. Then we got a learning target and your homework. Just a couple of things I want to talk about while you're copying that is that on Teams, a lot of you have done a really good job submitting your work. Remember, there's two options. You can write your work, handwrite it, which most of you are doing. Simply take a picture of your work and submit it on the assignment. Do not email it to me or post it on the chat board, which a couple people did, and I went ahead and deleted those. Make sure that you submit it on Teams. And then your homework, same thing. You can type it onto the Word doc that's there for you, or you could just do it on paper as we would do in class. Take a picture using your laptop and submit it. So both of those are good. So far I've only had one student mention they were not able to access YouTube, so I've been putting the videos on YouTube. But if you know of any of your classmates that do not have YouTube access at all for some reason, they'll need to let me know on Teams, and I will go ahead and upload the video under files for that particular period. So I need to know what period. It does take a long time to upload the videos on Teams, so that's why I've chosen to use YouTube. So make sure you spread the word and let people know who are feeling a little disconnected during this time. All of the assignments will remain open until Saturday night, and then they will close and you will no longer be able to submit anything on Teams until after spring break, because I just want to make sure that we're all having a necessary break. And then after spring break, we'll either see each other in class or we'll be back here online using the same process. Alright, if you haven't had time to copy down your DNA for today, you may want to pause the video right here and go ahead and finish writing that out. Alright, for those of you who are ready, take a look at your DNA. You're going to write the balanced equation for the decomposition of boron trifluoride. Now this is a molecular compound, so the formula is not given to you, but you should be able to figure it out from the name, boron trifluoride. So go ahead and write that formula on your paper, and it's decomposing. That means it's going to break apart. So this would be, right, a two-element decomposition. So it's going to break apart into boron into fluoride. Now looking at your periodic table, hopefully you have both your periodic table and your stoichiometry flow chart out. You're going to need both of those. If you don't, pause the video and grab them. Looking at boron, you'll notice boron is not highlighted, so boron is not diatomic, but fluorine is highlighted. So fluorine is diatomic. So when this breaks apart into boron and fluorine, make sure you pay attention to that. So go ahead and write the balanced equation and then interpret. Interpret in terms of moles, particles, and mass. If you're confused on that, go ahead and look at your DNA from yesterday or your notes from Tuesday. Closing it off with stating the law of conservation of mass, showing that both sides are mass is conserved, both sides are equal. And then you're going to write out the 6 mole ratios, just like we did in yesterday's DNA or Tuesday's notes. So take a minute or two, probably 3 or 4, pause the video, go ahead and do that, and come back when you're ready to see the answer. All right, hopefully you did the best you could on that and did really well. So this is the equation for the decomposition of BF3. That's boron trifluoride. Right, the equation looks like this. This is an unbalanced equation. This is boron trifluoride decomposing, breaking apart into boron and fluorine. You'll notice there I also included the states of matter, right, which are not mandatory, but they're good to know. Boron trifluoride is a gas, boron is a solid, and fluorine is a gas. So the next thing you should have done is balance that equation so that you have the same number of atoms on each side. And with that, we're going to need 3 fluorines, right, because we need some extra fluorine on the product side. And then we need to go back and balance those fluorines. So we have a total of 6 fluorines here. We're going to need 6 fluorines on this side. We only have 3. So we'll put a 2. 2 times 3 now gives us 6 fluorines. And the last thing we did was balance the borons. We have 2 borons. And now we have 2 borons. So there we go. We have a balanced equation. If you got any of those numbers incorrect, just go ahead and watch that process again by rewinding the video. All right, then we're going to interpret. We interpret in terms of moles first. That's where we get our mole ratio from. So you should be getting used to that. It should be getting pretty simple. You just put the word moles between the coefficient and the chemical. So 2 moles of boron trifluoride will decompose, this is our decompose, into 2 moles of boron and 3 moles of fluorine. Next, we're interpreting in terms of particles. When we think about particles, we've got lots of options: molecules, atoms, ions, and formula units. We know that boron is a molecule. Boron happens to be one of the metalloids, but it's on the side to the right of the staircase, and we know from the name boron trifluoride, tri is a prefix, so we know this is going to be a molecular compound. So we've got a molecule, and this one's all by itself. What do we call that? Yep, we call it an atom. And we've got fluorine. It looks by itself, but it's not, because there are 2. So it is also a molecule because it's a nonmetal. So your equation should have been interpreted like this. 2 molecules of boron trifluoride decompose into 2 atoms of boron and 3 molecules of fluorine. Hopefully you can mark that off as gotten that correct. Then we're going to do mass. Now remember, mass is when you need that periodic table. You need to add up and multiply by the coefficient. Right? That's probably where most people mess up, if they do, on the mass. Remembering that not only do you have to add the boron and 3 fluorines, but you got to multiply it by 2. You add up 1 boron, well, you don't add that, you just get 1 boron from the periodic table and you multiply it by 2. And then you add up 2 fluorines and you multiply it by 3. That's where those masses come from. So let's go ahead and look at that. With boron trifluoride, 2 boron trifluorides have a mass of 135.62. Now remember, if your last digit is different than mine, that's okay. It can go up 1 or down 1. Maybe that we use a different periodic table. For boron, 2 borons will be 21.62 grams. And finally, 6 fluorines. Remember, because 2 times 3 is 6, would be a mass of 114.00. Don't forget, all molar mass has 2 decimal places, so you can't leave those 2 zeros off. All right. Then the last thing we do is the law of conservation of mass, to show that mass is neither created nor destroyed. It is conserved. So we don't really have anything to add up on this time on our reactant side, because we know the value is 135.62. The question becomes, do these numbers add up to 165.62? And they do. So our last statement is that 135.62 grams reactants equals 135.62 grams of products, and we have proven the law of conservation of matter. So we give ourselves a nice cha-ching there at the end. All right, the last thing you were asked to do was the mole ratio. And remember, we've been doing those mole ratios now, just showing the relationship that comes from a balanced equation, because there is no chemistry. stoichiometry without a balanced equation. So we've been using these ratios: 2 boron trifluorides decompose into 2 borons and 3 fluorides. This is what your mole ratios should look like. In this case, this first example, we've got 2 boron trifluorides will produce 2 moles of boron. So we're relating 2 moles of boron trifluoride to 2 moles of boron. That's this relationship here. 2 moles of boron trifluoride produce 2 moles of boron. And then we do the inverse. We flip it over. And there's our second mole ratio. All right, our next relationship is going to be between the boron trifluoride and the fluorine. So here we have 2 moles of boron trifluoride. When it decomposes, it gives us 3 moles of fluorine. So the 2 moles of boron trifluoride, the 3 moles of fluorine, and we can flip that over, and there's our second mole ratio. Which means we only have one relationship left, and that's the relationship between our products. 2 moles of boron are produced at the same time as 3 moles of fluorine. So that'll be our last relationship. 2 moles of boron over 3 moles of fluorine, or 3 moles of fluorine over 2 moles of boron. Well, there you have it. I hope you have been getting comfortable with both interpreting and writing mole ratios. This is our last time that we'll be doing an example of this, so if you got stuck at all, just rewind the video and walk through the process again, or look at yesterday's DNA or Tuesday's notes. When you're ready, go ahead and draw a line under your DNA, and we'll jump into our notes for today. I believe we're doing 2 calculations on mass to mass. So this is part 2. I think this is actually part 3 for us. You might want to change that to part 3 on our 12.2 notes. Make sure you have your stoichiometry chart out. We're going to look at that first. Alright, so last chapter we were in the yellow only, and now with stoichiometry we're crossing this bridge. We learned yesterday how to find the mole ratios so that we could actually go from one side of the bridge to the other. That's what the mole ratio does. And remember, that comes from the balanced equation. The balanced equation is the only way to get back and forth. And so that was that was what we learned to do yesterday, to go from moles of A to moles of B. But what we're going to see today is we're going to start our first journey, and just like we did back in chapter 11, we were able to move all around this part of the table. Well, as it turns out, this side of the table is exactly the same. They are identical. The only difference is we have to get across the bridge to change a chemical. What I want to focus on today is this part right here. This is the heart of stoichiometry. And the reason for that is when we're doing conversions, we always go from mass of one chemical in an equation to mass of the other chemical. But as you notice, you can't go straight. That is not allowed. So to get from mass of A to mass of B, you're actually going to have to go around the table. You're going to have to start in mass and go down to moles. And then when you get to moles, you're going to have to go to moles of B. And then from moles of B, you get back to mass of B. So that is a 3-step conversion. Step 1, step 2, and step 3. So you're going to be using molar mass twice, but it's not the same molar mass. The first time is molar mass of A. The second time is molar mass of B. So 2 different molar masses. So that's what we're going to work on today. We're going to work on going from mass of A to mass of B, or we could even go from moles of A to mass of B. And that would be 2 steps. So both of those are what we're looking at in lecture today. We're going to ignore that part on the bottom. That's for another unit. Just the steps are the same. Make sure you have a balanced equation before you start anything. Go find your A and find your B, and then follow the chart. That's what we're going to do. Make sure you also have your calculator out. So here's our first problem. These are the same steps. These are on your stoichiometry chart, so there's no reason to copy them. And here's our first problem. How many grams of ammonia can be made from reacting 39.0 grams of nitrogen with an excess of hydrogen? All right, take a look at that equation. You don't need to copy it, but what you do need to do is write down your known and your unknown. So go ahead and pause the video as you write that down. All right, well, hopefully you selected the following: 39 grams of nitrogen as your known and grams of ammonia as your unknown. Remembering what we talked about yesterday, when we see excess, that means more than enough. So an excess of hydrogen means the hydrogen is not involved in this reaction. It's not going to slow us down. It's not going to run out, so we don't need to worry about it. Right? We do need a balanced equation. Remember up here where it says step 1? You must have a balanced equation. There's no stoichiometry without a balanced equation. This is an equation we've used before a couple of times, so you're going to need this equation. Nitrogen reacts with hydrogen to produce ammonia. Once we have the balanced equation, we have our known 39 grams of nitrogen, our unknown grams of hydrogen. Anytime you need to pause the video, do so, write it down, and then get ready to go. All right, let's go ahead and start with our known 39 grams of nitrogen. Now I want you to give it a shot and go ahead and set up the first conversion factor. All right, remembering your chart, mass of A goes from mass of A on the chart to moles of A. The conversion factor is molar mass. So you're going to need the molar mass of nitrogen. So go ahead and use that. Pause the video, set it up, make sure you do it right before you look at what I do. All right, hopefully you figured out that the molar mass of nitrogen is 2 nitrogens. So that's 28.02 grams. It goes in the bottom so that they can cancel, and 1 mole on the top. Cancel out the grams of nitrogen. We now have moles, and we're ready to move on to the next step. Now we're going to go from moles of A to moles of B, and we learned yesterday that that takes the mole ratio. So moles of A would be nitrogen, and moles of B, what we're looking for is the ammonia. So we go here to the ammonia, and we see that it has a 2 in front of it. So 2 moles of ammonia will be produced from 1 mole of nitrogen. That is our mole ratio, and that's our next conversion factor. 1 mole of nitrogen will go on the bottom. 2 moles of ammonia will go on the top. Again, the numbers came, these numbers, let me change the color here. These numbers came from the balanced equation. A mole ratios only come from a balanced equation. All right, then we're going to see what cancels here. Moles of nitrogen cancel out. We now have moles of ammonia. So taking a look back up here, we now have, we've got moles of ammonia, and we're going to go to mass of ammonia. We're going to need the molar mass of ammonia. So take a minute and add up the molar mass of ammonia. 1 nitrogen and 3 hydrogens. All right, The molar mass of ammonia, as you know from adding it up, is 1 mole of ammonia. Remember, the moles go on the bottom so they can cancel with the moles up here of ammonia. And we've got 17.04 grams of ammonia is the molar mass. Moles cancel out, and we're done. We now have what we were looking for, which was the mass of ammonia. Right, that was our unknown. Moles of B is the mass of ammonia. Do that calculation in your calculator. You're going to multiply 39 grams divided by 28.02 because it's on the bottom, multiply by the 2, and multiply by the 17.04. And you should have got a result of 47.4 grams of ammonia. Well done. That's our cha-ching. Good job. If you need to go back and see any of that, just pause the video and rewind. If you're ready, let's go ahead and move on to our second problem for today. What mass of calcium hydroxide will be produced from the reaction of 2.5 moles of calcium hydride with excess water? All right, there's several different things here, and there's a couple of chemicals you might not know the formula for. So I'm going to go ahead and give you the equation. This equation is not balanced. It's just the equation. So you're going to need to balance the equation and write your known and your unknown. So pause the video while you copy the equation, balance it, and write your known and your unknown. When you finish, come back to the video. All right, hopefully you did that well. Let's go ahead and see what our coefficients should be. You should have 2 waters and 2 hydrogens, and that would make the equation balanced. Our known, as we can see from the question, let's go back and take a look. What mass of calcium hydroxide will be produced from the reaction of 2.5 moles of calcium hydride? That's our known, and our unknown is what mass of calcium hydroxide. Again, you see this term excess, right? We've got more than enough water, or we're not going to run out of water. So we can go ahead and write in our known and our unknown. Notice the formula. The calcium hydride is the one with the hydrogen. The calcium hydroxide is the one with the hydroxide ion. The hydroxide ion, if you'll notice from your periodic table, is OH minus. All right, and a hydride is not something we've used before, but a hydride is actually an H, a hydrogen with a negative charge. Very strange. I know it got a negative charge by gaining an electron. Strange species we don't use very much, but just so you know, that's what a hydride means. All right, let's jump into the problem. I would start by looking at your stoichiometry chart. On your stoichiometry chart, you're going to find our known. We're starting this time with moles. Moles of A, and we're trying to go to grams, which you know is mass, of B. So moles of A to mass of B. That's going to be a 2-step conversion, right? Moles of A to mass of B. All right, let's start with our known. 2.5 moles of calcium hydride. To get from moles of A to moles of B, we're going to use the mole ratio. from the balanced equation, which we have already up here, nice and done for us. That's our first conversion factor. Our second conversion factor is from moles of B to mass of B, where we'll use the molar mass of B, which is calcium hydroxide. So pause the video and go solve the equation. Work all the way through the answer and then come back and check your work. All right, make sure you finish the problem before you listen to the rest of this. First conversion factor is the mole ratio. The mole ratio comes from the balanced equation. We have, let me change my color here. Actually, I'm going to erase some of this. Lots of writing on the screen makes it confusing. Right? So the mole ratio comes from the balanced equation. So moles of calcium hydride, there's an invisible 1 here. So that's what we should be writing, 1 mole of calcium hydride on the bottom. And we're trying to go to B. Our B is calcium hydroxide. So we look at the equation. There's also only 1 mole of calcium hydroxide in the equation. That's supposed to be a 1 there. Right? So that's going to go on top. 1 mole of calcium hydroxide. And there we go. Moles of calcium hydride cancel out. We got moles of calcium hydroxide. We only have one more step, and that's the molar mass of calcium hydroxide. You needed to add up 1 calcium, 2 oxygens, because of this little 2 right here, and 2 hydrogens. So you add up 1 calcium, 2 oxygens, 2 hydrogens. You get the molar mass. 1 mole of calcium hydroxide has a molar mass of 74.10 grams. Moles of calcium hydroxide cancel out. Put that all in your calculator. There's actually only 2 things you got to put in your calculator. 2.50 times 74.10. These ones over here, they don't do anything. You can ignore them. And you get 185 grams of calcium hydroxide. Now you might wonder, what happened to the decimal places? Well, we don't keep any because we only get 1, 2, 3 numbers because we're only starting with 1, 2, 3 numbers. All right, there you have it, ladies and gentlemen. You've got a couple of practice problems, one from mass of A to mass of B and one from moles of A to moles of B. Your homework problems are just like that. So go ahead and work those out and then submit the homework under the assignments tab. I'm going to create that assignment for you. And remember to submit your notes also under the notes tab. So you've got 2 assignments a day. The notes to show me that you're taking the notes and watching the lecture, and then the actual homework assignment, both submitted on their own place on Teams. Tomorrow again will be our last lecture before spring break, and you will have until Saturday night to get everything in. And then, well, for tomorrow's I'll give you till Sunday night. But for today, Saturday night will be the last day to turn in anything from last Friday's notes until today's work. Saturday night, and then tomorrow, Friday, I'll make sure that closes on Sunday. And then I don't want you to think about chemistry because you'll be on spring break for a whole week. And then we'll see each other the following week, hopefully at school. If not, I'll see you right here online.